Greetings everyone. Our topic for today's discussion is fuel cells as a source of energy. Before moving forward, I would like to introduce the member of our group, Ekta Namade, Sarthak Nere, Bhargav Patil, Rajesh Parchure, Pranav Bagul, and Raja Nafade. Moving on, we are going to discuss the following key points in today's discussion. Introduction to fuel cells, history of hydrogen fuel cells, application of hydrogen fuel cells, construction of working of hydrogen fuel cells, difference between fuel cells and batteries, advantages of hydrogen fuel cells, limitation of hydrogen fuel cells, contribution to sustainable development. What are fuel cells? A fuel cells is a device that generates electricity by combining hydrogen and oxygen in a chemical reaction. It is similar to a battery, but instead of using stored chemical to produce electricity, a fuel cell creates electricity on demand as long it has a supply of fuel.
Moving on, now we'll discuss the history of fuel cells. It was quite interesting how the fuel cells were invented. In the year 1800, William Nicholson and Anthony Carlisle were able to break water into respective atomic hydrogen and oxygen by using electric current. It was called as electrolysis. By using this, the scientist William Group was able to recompose water and create the first working gas battery in the year 1839. Now we'll look at the construction of the gas battery. Unlike any other battery, this was consisting of two electrodes which were of platinum, consisting of oxygen and hydrogen, submerged in dilute sulfuric acid, just like any other galvanic or electrolytic cell which has two electrodes and which is submerged in electrolytic solution. The sealed containers contained water and gases, and it reabsorbed that the water level rose in both the tubes as the current flowed. This gave William Group the idea that it was a working model of a gas battery. The device was nicknamed Group Cell, and it consisted of platinum electrode immersed in nitric acid and a zinc electrode immersed in zinc sulfate. Surprisingly, it generated about 12 amps of current at approximately 1.8 volts.
Someday soon, you could step into a car that produces zero carbon emissions or greenhouse gases. You could place down the highway next to efficient buses, delivery vans, and semi trucks that are equally clean burning. Even your office could be equipped with emergency backup generators that run not on fossil fuels but on hydrogen fuel cell technology.
Applications of the fuel cells are fuel cells can be used as power sources in remote areas for primary and backup power for commercial, industrial, and residential buildings. Fuel cells are combined with other auxiliary energy sources to form hybrid systems to supply energy to both hybrid and electric vehicles. Fuel cells are also used in wastewater treatment plant. It convert chemical energy stored in biodegradable portion of organic matter into direct electric current. Fuel cells could replace batteries in mobile phones and laptop or computers. Fuel cells are being incorporated into heavy-duty buses, trucks, trains, and cars powered by compressed hydrogen gas that feeds into fuel cell stack that doesn't burn the gas. Fuel cells are also applicable in the UAVs.
Till now, we have seen what are fuel cells, its history, and all the ways it can be useful and beneficial for the humankind. Now, let's see how a hydrogen fuel cell is constructed. A fuel cell is a lot like a battery, with a basic structure of two electrodes with an electrolyte in between. The electrode at the negative terminal is the anode, and the one at the positive terminal is the cathode. Both of these electrodes are porous, containing a suitable catalyst like finely divided platinum. The electrolyte usually used in a hydrogen fuel cell is hot potassium hydroxide, in which these porous electrodes are immersed. In order for a hydrogen fuel cell to work, it needs hydrogen and oxygen. The hydrogen enters the fuel cell at the anode. This hydrogen gas is supplied through a tank where it is stored. A chemical reaction strips the hydrogen molecules of the electrons
and the atoms become ionized to form H plus ions. The electrons then travel through a wire provi- to provide current to do work. The oxygen at the cathode usually comes from the air. The oxygen picks up the electrons that have completed their circuit. The oxygen then combines with the ionized hydrogen atoms and water is formed as the waste product, which exits the fuel cell. The electrolyte too plays an essential role as well. It only allows the appropriate ions to pass between the anode and
If other ions are allowed to flow between the anode and cathode, the chemical reactions within the cell would be completely disrupted. The reaction in a single fuel cell typically produces only 0.7 moles, which is too less. Therefore, fuel cells are usually stacked or connected in some way to form a fuel system that can be used in cars, generators, or other products that require power. In this image, we see the proper working of a hydrogen fuel cell in cars, generators, or other products that require power. Next, we will see the comparison between fuel cells and batteries.
Now, if we look at the storage of energy, fuel cells cannot store energy, whereas batteries are able to store energy. The chemical reactants are continuously supplied in a fuel cell, whereas in the batteries the reactants are contained in the cell itself. The reaction products are removed from the cell with the help of various exhaust ports, whereas the reaction products in the batteries remain in the cell itself. Fuel cells are not at all rechargeable, whereas batteries can be rechargeable. Fuel cells have high efficiency and batteries have less efficiency. Moving on, fuel cells supply energy for a long time, whereas batteries supply energy for a very limited time. Fuel cells are expensive and batteries are comparatively less expensive.
As you have brief idea about what fuel cells are, now let's jump into types of fuel cells. There are approximately 7 types of fuel cells. They are as follows. First is polymer electrolyte membrane fuel cell. Second is direct methanol fuel cell. Third is alkaline fuel cell. Fourth is phosphoric acid fuel cell. Fifth is molten carbonate fuel cell. Sixth is solid oxide fuel cell. And seventh is reversible fuel cell. Now, let's understand some advantages of fuel cells. The advantages of fuel cells are as follows. First, it is renewable and easily accessible. Hydrogen is by far the most abundant element on Earth, regardless of the difficulties in extracting it from water. It is particularly sustainable and limitless form of energy. Second, it is well component compared to other energy sources. Hydrogen fuel cells are more efficient in producing electricity than other conventional power sources, including many green power options. Third, hydrogen is dependable and adaptable power source that can help with zero carbon energy initiatives. Fourth point, more durable and energy efficient in comparison to fuel cells. The hydrogen fuel cell technique delivers a robust high efficiency source of power. By weight, hydrogen has the highest primary energy output of any conventional fuel. Fifth, minimizes carbon residues. Hydrogen fuel cells emit almost no greenhouse gases, implying a negligible carbon footprint when in operation. Sixth, minimal sound pollution. Hydrogen fuel cells do not generate excessive noise like some other alternative power sources, including wind energy. Seventh, they have the ability to adapt. That means hydrogen fuel cells would be equipped to provide power for various stationary and consumer devices whenever technology advances. And the final advantage is that they can be suitable for use in remote locations. Due to local constraints, hydrogen generation and storage can substitute diesel-based electricity and heaters in remote regions. Providing non-polluting energy derived from a locally accessible resource would reduce the need to import fuels and raise the standard of living for individuals residing in remote locations.
As we know, there are two sets of coins. Hydrogen fuel cells also have advantages as well as limitations. Following are some limitations of hydrogen fuel cells. First, hydrogen extraction. Despite being the most abundant element in the universe, hydrogen does not exist on its own, so needs to be extracted from water by electrolysis or separated from carbon fossil fuels. Both these processes require a significant amount of energy to achieve. Second, investment is required.
Hydrogen fuel cells need investment to be developed to the point where they become a genuinely viable energy resource. This will also require political will to invest the time and money into development in order to improve and mature the technology. Third, cost of raw materials. Precious metals such as platinum and iridium are typically required as catalysts in fuel cells and some type of water electrolyzer, which means that the initial cost of fuel cell can be high. The high cost has deterred some from investing in hydrogen fuel cell technology. And the next point is hydrogen storage. Storage and transportation of hydrogen is more complex than that required for fossil fuels. This implies additional costs to consider for hydrogen fuel cells as a source of energy. And the last point of limitations is hydrogen is highly flammable. Hydrogen is highly flammable fuel source, which brings understandable safety concerns. Hydrogen gas burns at air at concentrations ranging from 4 to 75%. A question might have arisen in your mind: how does fuel cells contribute to our sustainable development for our future? So, fuel cells are promising technology that can play a significant role in sustainable development. Here are some potential applications of fuel cells that could contribute to sustainable development. First is backup power. Fuel cells can be used as backup power sources for critical infrastructure such as hospitals and data centers. Compared to traditional backup generators, fuel cells are more reliable and emit fewer pollutants. Second, cogeneration. Fuel cells can be used in combination with other energy systems such as combined heat and power system. This allows for simultaneous generation of electricity and heat, increasing the overall efficiency of the system. Third is transportation. Fuel cells can power electric vehicles, providing a clean and efficient alternative to traditional combustion engines. Fuel cell vehicles emit only water and heat, making them a zero emission option. Our next point is clean energy. Fuel cells produce electricity without combustion, which means that they produce little to no harmful emissions such as greenhouse gases, particulate matter, or smoke forming pollutants. This makes them an attractive option for meeting increasing energy demands without compromising air quality or contributing to climate change. Our last point is renewable integration. Fuel cells can use a variety of fuels, including hydrogen, natural gas, methanol, and ethanol. Hydrogen fuel cells can be particularly useful in integrating renewable energy resources such as wind and solar into electricity grid, as they can store excess renewable energy in form of hydrogen and then use it to generate electricity when the wind is not blowing or sun is not shining. As we come to end of our presentation, let's conclude our topic with few lines. Overall, fuel cells have potential to play significant role in achieving sustainable development goals by providing clean, efficient, and reliable energy for a variety of applications. However, the widespread adoption of fuel cells will require continued investment in research and development, as well as supportive policies and regulations to create a market for fuel cells technology.